The most standard and common display would be transmissive display. So we have a transmission of the light from the backlight through the LCD. As we said, the LCD will be polarizers, LCD glass, another polarizer, electrodes, and then we have the surface of the screen, this black part, and we have the viewer, the user that is seeing the screen. Welcome at Riverdi University. My name is Kamil and I'm the founder and CEO of Riverdi. Today we will be talking about the most basic LCD displays that are, of course, monochrome displays. So we will talk about basic technology, what is behind there, how they work, how the pixels work, and this will be the foundation for our next session and lesson regarding the TFT. So we will add colors later and active matrix, but right now we'll be talking about the simple and the most simple LCD displays and technologies around it. Yes. So here is the short agenda for today. So we'll talk about TN, STN, FSTN, DFSTN, and other technologies. Then we'll talk about positive and negative displays, how they different from each other. We'll talk about the light, let's say, in a display. So we'll talk about reflective, transflective, and transmissive displays. And of course the backlights, viewing angles, this is a very important part, and the colors, because even in monochrome displays we can have different colors. Of course it still will be monochrome display, so there will be one color, one background, one character color, but they can be different colors. No need to be only black and white. So let's start with the basics. The technology of the LCD displays are related to liquid crystals, and the liquid crystal is a very special material that can change the polarization of the light. It's actually liquid, it's really liquid. It's put in between two glasses that we have in every LCD display. We put LCD crystals inside, and because of special properties we can change the polarization of the light using electrical voltage. Yes, so we generate electrical field in between these two glasses, and then we move the crystals inside, and in the same time we move and we change the polarization of the light. So the most basic display, LCD display, is a TN that we call twisted pneumatic. Yes, so it's the first and the oldest technology that we still use nowadays. Twisted pneumatic displays are used even in a TFT displays. So it's the oldest but used until today, and its working principles are the simplest. So first of all, we need to have two glasses where we put inside the liquid crystal. As I said already, we need to have electrodes. So of course they are transparent, made usually by ITO on the glass. So a special transparent conductive surface that allow us to generate electrical field in between these two glasses, two electrodes. And then of course we cannot just change the polarization of the light. It won't be enough to set on and off pixel. Yes, we need to have first polarized light. Yes, so what we do additionally to really have a display, we need to add two polarizers. One we add on the bottom and one we add on the top of the screen. And once we have the polarizer, we have the polarized light. So let's say in this case we see that the light is being twisted with these crystals when they are in an off state. So this display, we will call it normally white, because we see there is no voltage right now applied, but the pixel is white, so the light is being transferred through. So what we know from this picture is that the polarizers are right now in the right angles, and they are 90 degrees to each other. Yes, so first the light goes through the first polarizer, then it turns on the liquid crystals and go out through the other polarizer, and we see the pixel. But the magic happens when we actually apply the voltage. Yes, so we have the second image here, and when we apply the voltage, the liquid crystals become organized, and the light is not the polarization of the light is not changed anymore. It's not switched to the like 90 degrees position. So because we have two polarizers in a 90 degrees to each other, the light is going through the first polarizer, but it's not being turned, and it's blocked by the other polarizer this time. Yes, so by applying the voltage, we can actually switch on and off pixel. Once we can do it, we have a display. Yes, so we have a 1 pixel. Then from 1 pixel we can build like matrix of the pixels and actually present any image. What is more important and useful, this control is not only off and on state. We can actually control the states in between. So we will have something like a grayscale. Yes, so we can go from the white pixel to the black pixel with some steps. They could be like 16 steps or 256. Usually we do it through the bits. So it will be 16, 256 or more. For TFT, for example, it will be like millions, because we will have 24 bits, for example, which will give us 16 million combinations of the different pixel or 3 pixels RGB pixels brightness. Yes, we can say so. So this technology actually allows us to have a display working and present some images with the grayscale, but in a normal LCD, the monochrome LCD displays, it's usually not used because the technology is not perfect enough. It's a passive technology. There are no transistors connected to the cell itself, and controlling the brightness with the grayscale is really hard. So usually it's not done here. It's used in the other technologies like TFT that we'll be talking later, but here we usually have only on and off state to have the clear image. So let's go further. Once we know how the display works, how the cell is working, and we know that the most basic is a twisted nematic display, we have some other variants. There are many of them actually, but next I would say that is super popular would be STN. That is super twisted nematic. Is the technology that allow us to reduce the voltage to control the display, which is very useful when we have battery powered devices, or it's also useful because we can connect the display directly to most microcontrollers that work, for example, on 3 volts or even lower voltages, so we don't need a special drivers. And the other very important advantage is it's a better contrast. So we can see the image more clear. We talked about the contrast in the previous video, so you can learn more there. But the contrast, the voltage, and actually it can be faster. Yes, so STM can be faster. That means we can refresh it faster, and the image, if we have, it can even move or be more clear when we change something on the screen. Okay, here we have another variation of monochrome displays. It's called FSTN or DFSTN. That is like film compensated, super twisted nematic. So it's additional layer actually that we add on the glass that is making the display even better. Yes, and what I mean better here is like having the higher contrast than the regular TN or STN. Once we add the film, we can go to the more black, let's say, background. As you can see here, FSTN display from Winstar company, that is our partner, and the next display is a DFSTN, so it's additional film. So we have double FSTN, so two FSTN layers, and the contrast is even better. As you see, it's more black. These technologies, of course, add cost to the display. So the cheapest one will be TN, then STN will be a little more expensive, and the FSTN and DFSTN are more expensive even. And these technologies, even if they all look very good here, they are not perfect, because when we go and we change the angles of a display, then we see that the contrast is being lost very fast. So these kind of technologies are useful, but in some in application where we actually look on the screen straight, most useful, let's say. Yes, if we want to see the display from the angles, there are other technologies. Of course, TFT is one of them, or OLED technologies that are way better than the monochrome displays. But monochrome displays are very popular still, because this technology is well known, established, and cheap. Yes, so these displays are usually the lowest cost displays that we can buy on the market. Next screen. Okay, so another variation is HTN, so high twisted nematic, something that is a little bit different but similar to STN. It was mainly made for automotive industry, and the voltage here is even lower, but actually HTN have the main advantage that is very wide temperature. So it's just an example that we have many of the different options when we choose TN based displays, either STN, FSTN, HTN, and other technologies, ASTN. It always depends what kind of application we have, what kind of environment, I mean temperatures, what kind of light, and the colors that we need. Okay, so let's jump right now to the explanation what is a positive and negative display. So basically, as you can see, it means like the active state of the pixel. Yes, what we see as a pixel and the background. So in positive display is like the most simple, is like a calculator, let's say. So what we see on the background is just the LCD in a normal state, usually some light color, or the background color from the backlight. Yes, in this example will be like yellow-green background, the most common backlight for the STN displays, and the pixels are black. Yes, so this is the positive. In negative we have completely opposite, so the light is being blocked in the background. Here we have the blue, because it's like a property of STN display that when we put the white light under it and we make a negative colors, the natural color of the LCD will become blue. But when the pixels are not blocking the light, we see the white pixels. Yes, so actually the backlight here is a white backlight. Yes, and it's not blocked where we have the pixels. So we have positive and negative. They are, again, like where we can use them. Positive we usually use when we have the like regular environment with the light, and we don't need the backlight. Yes, so in positive display it's possible to switch off the backlight and we still see the image. It's like, as I said, like a calculator, for example. We don't need a backlight there because it's a reflective display or transflective. We'll be talking about it later. But in a negative display, we need always the backlight. Yes. So when you choose the display and you think which one would you like to use in your application, think about the power consumption. If you have a battery powered device, then probably the positive display will be better, because it will allow you to switch off the backlight, which is the main current drain, the place where we need to put the most power. And for negative, you need to have the backlight always on. Yes, so you cannot switch it off. If we switch off the backlight in a negative display, we will not see anything. So it's rather not for battery powered devices. Okay, now we will talk about 3 different technologies used in a monochrome displays, and how the light is being transmitted and what we and how we see the image. Yes, so the most standard and common display would be transmissive display. So we have a transmission of the light from the backlight through the LCD. As we said, the LCD will be polarizers, LCD glass, another polarizer, electrodes, and then we have the surface of the screen, this black part, and we have the viewer, the user that is seeing the screen. So in a transmissive LCD we have transmission of the light. As I said, it's the most simple one, but in a transmissive display we need to have the backlight always on. So this kind of display will be, for example, negative, but not necessary. It could be positive display as well, but the backlight in transmissive display need to be always on. Okay, the next display that is pretty simple as well would be reflective display. So this kind of display, in a most basic example, have no backlight at all. So the example here will be again a calculator. We don't have the backlight there usually at all. We just use the environmental light which is being reflected. And how it's being reflected? It goes through the LCD and then it's being reflected on the mirror that is on the back of the screen. Yes, so the back of the screen is a mirror. The light goes back. Yes, so we have a reflection here, and some variation of the reflective display could be a reflective display with the front light. Yes, so we have the same stack here from the back. So we have the mirror, then we have LCD, but we have the LCD that is actually the front light LED, not the backlight here. So it's a front light, and it's giving us the light that is being reflected later inside this mirror. And the last one, as I said, we have three of them. So the last one will be transflective. It's like a combination between transmissive display and the reflective display. So it uses both phenomena, let's say. One is to use reflection and one is to use transmission of the light. So to use it both, we need to have something that is called semi-mirror. The mirror that is actually reflecting half of the light more or less, and it's also transparent to another half of the light. Yes, so in this kind of display we can use external light to be reflected, and then we can switch off the backlight. But for example, during the night when we have no external light, we can switch on the backlight, and then we can see the screen again. This kind of displays in monochrome, I would say, are the most common. They need to be positive, the same as reflective displays. They need to be positive to achieve this reflection. But they are common, as I said, because we don't need the backlight during the day. We can use backlight only during the night, let's say, or when it's dark. So we can save quite a lot of power. Yes, so this display is the most common. Okay, the next one we will talk about the backlight types. So basically for monochrome displays we have two types of backlight. One is most popular right now, which will be the edge light, edge backlight. So we have the LEDs only on the edge of the, not on the screen because LCD is here, but under the LCD we have a diffuser, and the LEDs are on the edge of this diffuser, and they are pumping the light inside the diffuser. Then the light is being reflected by the mirrors and go out through the LCD. And this is the most common right now, the cheapest way also to build the backlight, and very efficient, because nowadays LEDs are very efficient in the power consumption, but also like the light generating. But the other more let's say mature technology, older technology from the past, was to use the backlight LEDs usually on the whole surface of the LCD. So we literally light the LCD from back, yes, from the whole surface, and it's rather not used anymore because this is more expensive. We need a big PCB or FPC to put LEDs behind LCD. We need many LEDs to have the light, let's say, uniform enough. So this technology is not used for monochrome anymore. It's only used right now for TFTs, for something that is called local dimming in very special TFTs. Maybe we'll talk about this in some further video. So as I said, right now on the edge backlight is used. Okay, the next important point is like viewing angles. So for LCD technology is quite important to understand that the image that we see when we look straight on a display can be completely different than we see it from some angles, and this is usually very well described in a data sheet. We talk about the viewing angles, and they need to be defined there, yes? So it should be like, 50 degrees, 60 degrees, 70 degrees, or the best TFT display will have like 89 degrees. But it will be defined. For monochrome, usually the numbers are lower, and basically the viewing angle is like the maximum angle that the user see the clear image, yes, on the screen. So very simple definition. Of course, when we measure it, we have the more defined definition because it's usually being measured by a camera, so we measure the real contrast when we move the camera with the angles over the screen, but later, of course, for the user it's the same. So when we are too far with the angle, then we will not see the image clear, or we will not see the image at all. So it's very important to remember. Okay, I mentioned in the beginning that we have also colors for monochrome displays. Of course, as I said, there is only one color for the backlight and one color for the characters. But as you can see here on the backlight type, there could be many of different colors. So we can have white